Hello, boys and girls. So the first thing that you're going to do is you are going to check your work from page 340 and 341. Zoom in to see it better. There are 20 points. Please pause the video to do that. So I squeezed 2 pages onto here so that we could save slide space. So correct page 342 and also page 343. You'll need to pause the video to do that. Once you have that done, we are going to put all 3 scores together, and it should be out of, I believe, 20 points. So please make sure you snap a picture of 2 of the 3 pages. I won't make you do all 3, so you can pick and choose, and your score on page 340 out of 20, please. So you will notice that we are in Unit 8 now. We skipped over a few things that Mr. Smallfield and I thought might be a little bit harder for you to do distance learning. Your lesson today has to do with perimeter and area of rectangles. Your I can statements are I can practice solving problems with perimeter and area, and I can find the unknown side length of a rectangle. So you're obviously watching this Explain Everything video now. You're going to complete page 361 and worksheet 8.3 for homework. So I put in the top of, I think this is page 300, I can't remember exactly what page it is. It's got to be 360, I think, if you want to look at that in your journal as I go through. And perimeter is the distance around a figure. So you can see my cursor here is going around. That is the perimeter of that figure. And in this case, the easiest way to find that is to take 3. Oops, let me get to a better pen here. You're going to take 3 plus 3, because this side is also going to be 3. And then you're going to also take 5 and 5 more, and I'm a little off kilter here so you can see that I'm adding it up here, and you get 16. So the perimeter of this figure is 16 centimeters. So the formula for this can be written a couple different ways. The way we did it was 2 lengths. Sorry about that, boys and girls. So the next thing, we're going to talk about the formula for that. It is 2 of the lengths, and we'll do L for lengths, plus 2 of the widths. We'll do W for widths. So what we did was 3 plus 3, that would be the 2 there, and then we did 5 plus 5. Another way, obviously, to say that is you could multiply 5 times 2, and that's where the 2 smushed next to the width means that, and the 2 smushed next to the widths could mean 3 times 2. Okay, and then the area is the total number of square units that cover a figure. A unit square has an area of 1 square unit. So when you were little, you used to count up and say, oh, there's one there, and 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 count up all the different squares in there. But now, since you're a little bit older, we're moving towards the formula for that. 5 times 3 equals 15, which is faster than, make sure that looks like 15. That's a little faster than counting up all 15 squares, saying 1 plus 1 plus 1. So the formula for that is length area equals length times width. And you're going to need to know that to find the area and the other formula for the perimeter when you add up all the way around the sides. So this one has a lot of fraction problems on it, so I have crossed those out. Those are ones that we haven't talked about. You do know how to add up fractions. Many of us have learned how to multiply fractions, but not everybody is as comfortable with that. So we'll just do the decimal numbers and the whole numbers. So you really only have to do problem 9, oops, let me get to a pen, 10, or 9, 11, and 13 on this to find the area and the perimeter. And then on number 11, you're going to actually do a division problem on that one because you know the answer equals, get to a pen again, not 229 and 76/100ths. And so the division problem you would do would be divided by 4 and 8/10 meters. And you can do that on paper pencil, or if you would like to do that with a calculator, you could also do that too with a calculator to help you to make it a little easier since we're not there to help you. And then the same thing, you're going to take 62 and 72/100 square meters, and you're going to divide that by 5 and 6/10. And that is how you get to the answer for how many centimeters would be on that length. And again, please feel free to use a calculator for that one. All right, so same I can statement I just had left up. The next one from the last lesson, I forgot to switch that. And so these I can statements I think are wrong, but the ones on the last page are correct. So the first thing that you're going to want to do is you're going to want to zoom in on this worksheet 8.3. You're going to have to write this paper pencil, so find a scrap sheet of paper and then you can write that out. We're going to do problems numbers 1. We are not going to do problem 2. We will do problem number 3, very similar to what you did on the journal page. We will not do problem 4. You can do problem 5. We will not do problem 6. And we will not do 7 or 8 also. Get to the right pen there. So really only 3 problems on this. Now, of course, if you would like to do the problems that have fractions in them, you are very able to do adding fractions where you just would have to make sure you have common denominators. And if you're comfortable with multiplying fractions and you would like more practice, you can do that too.